Welcome back. Hope you had a good weekend, like the Cowboys did. Victory Polo Monday yet again. Keeps happening. All right. Well, anyways, you have that objective written down. It's a new one for today. Always write down your objectives for your warm-up sheet. Easy 100 every week, right? Okay. So you're going to be able to identify and apply properties of parallel lines cut by a transversal. We're going to talk about all that. We're in a new unit, right? So last Friday we did a quiz. Some people are still finishing. We'll go over that this week. But we're actually officially in Unit 2 now, so cool. What's next? Okay, so did you define parallel and perpendicular? I hope you know what these words mean. So what does parallel mean? Parallel is what? What? Not same on each side. Well, I don't know what you mean by that. But what? Lines that never intersect. Very good. Parallel is when lines never intersect. Now, by the way, they're on the same plane. We're going to see the difference between parallel and skew. That's another word. We'll talk about that later. But basically, on the same plane, it's when lines never intersect. Okay. Perpendicular is what? Okay. That's part of it. So it's when, bless you. Okay, some people would write right here, perpendicular is when two lines intersect. And that is almost right, okay? Did you know two lines can intersect and not be perpendicular, right? So you want to be specific. They intersect at 90 degrees, okay? So don't just say 90 degrees. Say when two lines intersect at 90 degrees, okay? Okay, and you want to draw an example of each. So parallel lines go in the same direction, not intersecting. And then two lines intersecting at 90. So make sure you have those two definitions and little drawings there. And we are going to do some notes on this stuff. Okay. Let me pass this out and we're going to get started on lines cut by a transversal. Everyone's got these notes? Now, we're going to name pairs of angles formed by a transversal. Now, that's our first word, vocab, for today. And by the way, no one's got headphones in our ears because we're listening, and this is brand new stuff, and it'll be real quick, and we'll get to the assignment if we can just all be focused. So, a blank is a line that intersects two or more lines in different points. This is a transversal. Okay? So, transversal, that prefix means across something. So right here, it would probably be smart every time you see one line, try it again, one line going through two other lines, put a little T next to it. Okay, that's a transversal. There's already a T there, but maybe highlight it or circle it or something. The one line that goes through two other lines is a transversal, right? By the way. Oh, well, it's an emergency. Do what you gotta do. What? True. So, next, blank. Blank angles are two angles that are in matching positions. Let's underline that. Matching positions at the two different intersections when a transversal cuts a line. These are called corresponding. Don't know what the word corresponding means in general? All right. Usually you correspond with someone, like talk to them or reply to them, but corresponding just means same position, same location, kind of in a different place. Okay? So what I think of it is like, you got like a parking space in one aisle, and you go over one aisle, it's the same parking space. Sometimes you're like, I thought I parked here, but you really went over, okay? That's the idea. So let me show you what it looks like. Corresponding looks like this. So go ahead and put a little arc right there. Now, this arc is at the bottom right of this intersection, right? Now go down here. You're going to put an arc at the bottom right of that intersection. Do you see how they're both in the same position at different intersections? Bottom right, bottom right. Now it could be the same for top right, top right. Top left, bottom left, bottom left. Okay? So, here's the deal. For our angles, we're going to kind of shade the angle. So this top angle is this and this. And then the other angle is from this and this. Now, off to the right, it says corresponding angles form the letter what? Looks like an F, right? Those two angles, if you shaded them the way we just did, looks like an F, okay? So let's do two more examples down here. This is on the left side, so over here I'm going to go to the left side. Same exact position, okay? So just a note, they're on the same side of the transversal, but one's inside and one's outside of the parallel lines, okay? So you see the parallels? This one's inside the parallels, this one's outside the parallels, but they're on the same side of the transversal, right? T for transversal. Let's label all these T's. There's a T, there's a T. And we know T stands for transversal. Label those T's real quick, okay? And I'm shading these angles. Now, does that look like an F? No, but it's a rotated F, okay? Like, as long as you tilt your head, I guess. Let's do another one over here. Could be like this and this. Upside down F, that's fine too, okay? So again, same position, different intersection. They're on the same side of the transversal. One's in, one's out, okay? This is probably the harder one, because I think the other ones that might be easier to figure out, okay? So that's corresponding, all right? So the objective today is to be able to tell when you have corresponding angles, okay? And here's something you need to know about corresponding angles. So fill in this blank. Corresponding angles are, and I want you to notice, these angles, don't they at least look like the same measurement? Acute and acute, right? So when you're doing these types of problems, what looks the same is, okay? Corresponding angles are congruent, okay? And the easiest way to remember that, C is C. Corresponding are congruent. So let's make up an example here. If this was 82 degrees, and this was X, what does X equal? 82 degrees. Okay? So, on an assignment, if you see corresponding angles, and one of them's labeled, label the other one. Easy. Yes. Okay. Next one. Before we get to the next ones, we need to know what interior and exterior angles are. Okay? What does interior mean? Inside. What does exterior mean? Outside. Pretty easy, right? So, interior angles are between the parallels. Right there. Interiors are these four angles. So there's four angles between the parallels, okay? So exteriors are outside the parallels, not between the parallels, but however you want to say it, outside the parallels. So there's two places, over here and over here. Exterior. Exterior. So this one and this one in green, this one and this one in green. So if you're thinking of like a sandwich, the exteriors are the buns and the interiors are the ham or the turkey or whatever. Okay? There we go. Or baloney, right? Like when people say the Cowboys are going to lose, baloney. Hey. All right, so. Hey. All right, so blank angles are two interior angles. There's part of the help. On opposite sides of the transversal. Now, we're not going to use the word opposite. We're going to use the word alternate. And do you know alternate means different sides? Okay, if I alternate, both side to side, like when I'm juking, get a touchdown. Woo. So we call these alternate interior angles because they alternate for the transversal and they're interior of the parallel. So, real quick, it should take you 2 seconds. I want you to label T on all three of these little figures here. See if you can beat me. T, T, T. Oh, I got beat. This time. Okay, now, let's label some interior angles that are alternate the transversal. So, I'm going to label one interior angle, and there's one. Okay. Now, you want to label another angle that's between the parallels and on the other side of the transversal. So that would be right there. Try that a little nicer. Boom. Do you all agree? That's between the parallels, different sides of the transversal, alternate interior. Now, we're going to do the same thing like we did before. We're going to kind of shade the edges of the angle. So there's this one, and this one. And then there's this one, and this one. Now that kinda looks like a what? Kinda like a Z. I know it's a weird Z, but alright, so over here off to the side, do another one. We can try this one and this one. Now, because it's rotated, it looks more like an N, but you get the idea, right? Rotated Z, N, whatever. And then what about this one and this one? Now that looks like a flipped over Z. Yeah. So you get the idea. It's alternating and in between the parallels. So now I'm going to abbreviate. Alternate interior. Now you tell me, kind of just give it the eye test. Do those look like the same angles? Okay, they're both acute. Both acute. So it works out, okay? Or they could both be obtuse as long as they match. So alternate interior are also congruent. Okay? So the alt is congruent. So far, corresponding are congruent, alternates are congruent. Yes. Restroom? Take the pass real quick. Okay, y'all ready to flip it? Okay, flip it. Okay, so we just did alternate interior, okay? And now we're going to do another interior, but instead of alternate, it's going to be on the same side, okay? So we got two angles on the interior and on the same side of the transversal. We call that same side interior. Same side interior. Cool. All right. So, I'm going to pick one of my interior angles. I'll pick this one right here. And now I need to label another angle that's interior, but it's on the same side of the transversal. By the way, let's label those transversals real quick. Put a T on the transversal. T, 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 right? Transversal. Okay, so on this one right here, this angle is above the transversal. So the only other angle above the transversal between the parallels has to be right here. Put 2 arcs on that, okay? So those 2 angles are on the same side of T and in between the parallels. So once again, if we shade the edges like this, we get a square looking what? Kind of like a square looking U. Or maybe a square looking sideways C. Okay? Over here, same thing. We could pick this one and this one. Kind of weird. We could pick this one and this one. As long as it's between the parallels and on the same side of the transversal, okay? Now I want you to notice, okay? Let me put my cursor on it. This angle right, hard to do. This angle right here is acute, and then this angle right here is obtuse. Okay? So if one's acute and one's obtuse, are those congruent? No. Okay? So again, when you're doing the eye test and you're looking at this, hey, that's less than 90. Hey, that's greater than 90. They're not congruent. Okay? So we're going to say same side interior, and we're going to abbreviate again. Same side interior angles are supplementary. Okay, so check it out. These 2 angles, if you put them next to each other, they would make a straight line, which is 180, which is supplementary. Okay, so the same sides are supplementary. How can we remember that? Same sides are supplementary. The S's are S. Same sides are supplementary so far. Right? Okay? So, we know that. Now we just did 2 interior angles. So you might be catching the what I'm teaching you so far. So we're going to do the next 2 kind of on a shorter scale. So we just did 2 interiors. Now we're going to do 2 exteriors. Okay? So right here. So, what kind of angles are exterior on opposite sides? Okay, instead of opposite, we use the word alternate. Okay, so these are alternate exterior. Write that down, please. Alternate exterior are going to look like this. I'm going to mark an angle on the outside. So see how it's outside the parallels? And now I'm going to go on the whole other side of the parallels, on the other side of my T transversal, which is going to be right over here. So take a look at this real quick. Angle outside, outside the parallels, different sides of the transversal. Okay? Now this does not make a fancy letter because they're all separated. Okay? So this is the only one. These next ones are, I don't have a letter to show you what it looks like, right? Okay? Well, the next one will be the same, but similar. Okay, so now alternate exterior are what? Now, what do you think? Do these look congruent or supplementary? Okay, congruent, because look, that's acute, that's acute. They match. So alternate exteriors are congruent. So both alternates are congruent. Corresponding is congruent. Do this last one here. What angles are exterior on the same side? What do you think we call that? Same side exterior. Same side exterior angles are on the same side of this T, transversal, outside of the parallels. So here's one right here, outside the parallels, and then on the same side, on the other side, do you see how that's on the same side of the transversal, but outside the parallel lines? Let's abbreviate. Same side exterior. And again, let's take a look at this just by eyeing it. If this one's obtuse and this one's acute, are those congruent? No, they are supplementary. Because again, look at those two angles. You put them next to each other, they're going to make a straight line, 180 degrees. They are supplementary. How do we remember it's supplementary? S, S. Okay? So if you haven't been catching what I'm telling you, okay? The S ones, the same side ones, are both supplementary. Same side is supplementary. S is S. Only for y'all. Yes. Transversal. If they make perfect 90s, then all the angles are congruent. So then it's still supplementary and it's congruent at the same time. Alright, so check it out. All the same sides are supplementary, and the ones that are congruent are alternate interior, alternate exterior, and corresponding. So alternates and corresponding are congruent. Last thing real quick. I'm going to show you a little trick. So if all of that was confusing, I'm going to show you the easiest way to tell what's the same and what's not the same. You ready? Okay. I want you to put an arc on all the acute angles. So I'll start with this one right here. Okay. We're going to put one arc on all the congruent acute angles. So this will go here. And guess what? These are vertical angles. So that's the same. Cool? And then down at the other intersection, this is acute. These are vertical angles. That one's also acute. What do you notice about this pattern? What do you call this pattern like this? I wouldn't call it parallel, but you could say they're alternating. The very non-mathematical way of saying it is that they're going in a zigzag, okay? Like this. Those are all the same. And you notice how there's 4 obtuse angles left over? I'm going to do that with 2 arcs. Those are all the same, but obtuse. So you can label that too. Label all these obtuse angles with 2 arcs. So the question at the bottom, what pattern do you notice that in a zigzag, alternating, all those angles are the same, and the leftovers, those are all the same too, okay? So if you want to actually draw the zigzag, ziggity, ziggity, zag, those are all the same, okay? Now, let's put some numbers on this real quick, okay? Let's say that this is 77 degrees. You know, let's put a number, put 77 degrees right there, okay? That means you know for sure 33, sorry, not 33. You know 3 other angles are also 77 degrees, right? What else is 77? Well, this one, and this one, and this one. Do you see how it's alternating? If you know one, you know 3 other ones immediately. Okay? And then here's the question. How do I find the blue ones? What do I do with 77? Subtract it from a straight line, 180. Okay? So let's figure that out. 180 minus 77, 103. So guess what these other 4 angles are? 103. Okay? Label that. So every time you see that figure with one angle labeled, you should label every other angle automatically, because you know in a zigzag they're all the same, and then the other zigzag is subtracted from 180. Okay? So that's the pattern of what we're doing. We have an assignment where you're going to identify the angle pairs, and then you're going to find a missing angle for me. Okay?